Hi guys, it's Ayla here and welcome back. So in this clip we are going to learn how and which options we do have in RFM to set member eccentricities. We are going to use these beams here as an example, and as you can see on the right side, I have them shown in different perspectives. So on the right bottom down here we have a top view and a side perspective at the top. Now let's say the structural planes of these beam members here in the middle should not be connected at the web of the other members as they currently do, but they should be connected over a certain offset or by a certain distance. First, I'm gonna select these beams in the middle here with pressed Ctrl key, and then with double clicking we can open the Edit Member dialog box. Up here we can find in the Options tab Member Eccentricities, and if we click on the right side here we will enter a new dialog box to create a new eccentricity. So basically we have two options. We can set either an absolute offset or a relative offset. With the absolute offset we can manually enter a certain value, for instance in reference to the global axis, as the absolute distance to the previously used system lines. Let's say we want to move the members upwards in the global z direction, so we just have to enter an eccentricity, for instance of 200 millimeters for both the member start and end. Then we click OK, and now if you have a look here at the side perspective, if I click OK once again, the beams are getting placed upwards. In the wireframe model we can see that even better, so here you can see the connection. The option relative offset allows us to create eccentricities for certain members depending on adjacent members. For the case that these members here in the middle should be flush with the other two beams on the right and left side, we can use this option. We can also enter the dialog for eccentricities directly using the project navigator. With the right click on member eccentricity, and then we choose new member eccentricity. So by defining the point in the middle of the top flange, as shown in the figure on the right side, we can attach the middle beam members with their top edges to the other beams. So we click here on transverse offset and then choose the reference member out of the model, and then as axis offset we select the middle point down here. So right now we have created the eccentricity, and as a next step we have to assign it to the members. We can do this with right click and then choose assign members graphically. In order to select the entire beam member, try to click in the middle of the members, like here, and then we click OK once again. So as you can see, the beams are automatically moved and we've just created a flash connection between the members. It's also possible to edit the eccentricities if we right click and then choose edit. Let's say this time we need that the bottom edges are connected to the top edges of the other members. Then we click OK once again. In the relative offset dialog section, there is additionally the option of actual offset down here, which allows you to connect members eccentrically to the flange of members. If we want to have this for both sides, we have to click both member start and end. Now have a look at the top view, so the members are connected flush on the edges. We can not only create eccentricities between members, but also for adjacent surfaces. So as you can see for this model, the top edges of the two beams here should be connected to the bottom edges of the surface. So for this, we basically have the same procedure. And instead of member here, we choose surface. Then we are going to select the surface out of the model, and as axis offset we select the bottom edge down here and click OK once again. Now we have also a flash connection between members and the surface. As the last part of this video, I also want to show you what you do have to consider during your calculations. For that, I've prepared a very simple example. You can see here two beam members. The first one has an eccentric connection here at the supports, and the second one does not. I've applied for both members a member load of 2 kilonewtons per square meter, and we'll run the calculation for this. If we have a look on the results now, you will notice that the first member has boundary moments and the second does not. So this is caused by the eccentricity, as in the background a connection to the original node is created. So please don't forget to consider this point. And thank you for watching, and if you like this video, don't forget to like and subscribe.